Webb Voyager has recently found something odd in space that may put our star and the entire nearby planetary system in danger. People say that Betelgeuse, a very large star, is about to explode in a supernova. What will happen to our planet then? What does the world need to know? Let's find out. The James Webb Space Telescope once again makes all the difference by showing that Betelgeuse, a huge star, is about to explode incredibly. Because Betelgeuse is so close to Earth, its supernova will be bright enough to see during the day for a long time. Everything began with the odd events of 2019 when Betelgeuse, a star on the verge of death, started dimming all of a sudden, which led to speculation that a supernova was imminent. Though its brightness changes from time to time, Betelgeuse is thought to be the 10th largest star in the night sky. It's not hard to see why. The star is extremely large, unlike most stars, and one of the closest stars to Earth, only 650 light-years away. It's believed to be around 8 to 10 million years old. At this distance, light takes 650 years to reach us, a fact both professional and amateur scientists find intriguing. This Orion red giant star has grown to become the second brightest star, just behind Rigel, the brightest blue star. However, Betelgeuse, the most notable and fascinating star, has been behaving quite unusually for the past few years. The star's light has dimmed significantly, which researchers first noticed in 2019. Some believe that it is about to explode in a supernova. Researchers have also stated that the star had partially exploded and lost a lot of its surface, which could be observed. It's also said to have less fuel in its core than it did years ago. The star's core will collapse into a black hole when it consumes the last of its fuel. This will launch the star's outer layers at speeds of up to 25,000 meters per second. The name for this fiery death is a supernova explosion. For Betelgeuse, it is said that it will be a beautiful sight for people on Earth to see. This is Betelgeuse, a huge, bright star that has used up all its hydrogen fuel at its core. Helium is now being fused into heavier elements. It's easy to spot the decline in a star's brightness when it runs out of fuel. Stars that lack enough hydrogen must use extra energy to ignite the helium created when hydrogen fuses with itself. This process causes stars to expand many times larger than before, becoming cooler and more red in color. Astronomers say Betelgeuse is enormous. Its outer atmosphere consists of hot gas that would reach far enough to engulf even Jupiter if it were at the center of our solar system. Betelgeuse is not a smooth ball of plasma. Instead, it's a lumpy collection of hot gas bubbles covered in dust clouds it has emitted. This makes it hard to determine its exact width. Knowing Betelgeuse's size is challenging, but its remaining lifespan depends on this. In a recent study that sparked much debate, astronomers led by Hideyuki Seo from Tohoku University in Japan suggested that Betelgeuse might be larger than most experts think. Betelgeuse is known to swell, shrink, dim, and brighten constantly, so this theory could be plausible. Betelgeuse's brightness fluctuates significantly. This cycle repeats every 420 days, which scientists believe results from a central mode, the periodic expansion of the star's envelope or outer layer. However, there are other odd things that frequently occur with Betelgeuse, which scientists attribute to more turbulent processes within the dying star. One of these changes occurs every 2,200 days, and researchers aren't sure why. The group led by Seo proposed that this 2,200-day oscillation might be Betelgeuse's primary pulsation mode, while the 420-day light change may be a secondary mode. Seo noted that the exact amount of carbon within Betelgeuse is still uncertain. Based on growth models, carbon depletion should occur within 300 years. After this, heavier elements would likely fuse together within a few hundred years, eventually causing the core to collapse and the star to explode in a supernova. This would be fascinating for skywatchers. The last time a nearby star went supernova was in 1604. Stars regularly explode somewhere in the sky, but most are too distant to see without powerful telescopes. Will Betelgeuse's impact reach Earth? If so, what would happen? Although it would be a spectacular cosmic event, understanding the potential consequences of a nearby supernova is essential. Supernovae are extremely powerful events that emit immense amounts of energy. As it travels through space, however, this energy quickly dissipates. By the time Betelgeuse's supernova reaches Earth, its energy would have significantly diminished. When will Earth researchers believe that even a cosmic explosion that occurred within 25 light-years of Earth wouldn't directly harm it? Gamma rays are one type of energy that cosmic explosions emit. Gamma ray bursts, or GRBs, are exceptionally energetic releases that can occur during some supernovae. However, for a GRB to have a huge impact on our planet, it would need to be pointed directly at Earth. The chances of an immediate hit from such a cosmic explosion are tiny. It's unlikely that a cosmic explosion would harm life on Earth directly, but it might have some effect on the climate. An explosion of ultraviolet radiation could be sent high up into the atmosphere by the impact, temporarily depleting the ozone layer. Studies, however, show that the ozone depletion would be small and short-lived, causing only minor environmental risks. In the recent past, it was suggested that if Betelgeuse went supernova, it would likely be bright enough for people on Earth to see. The impact could be as bright as a full moon and would be a beautiful sight at night. Astronomers and stargazers would have a unique opportunity to witness this astonishing event. Researchers have noted that Betelgeuse's eventual supernova would be a fascinating cosmic event, though it's not likely to have a direct effect on Earth. The gamma-ray burst is 640 light-years away, so it likely wouldn't have much of an impact, given that the energy is spread over such a vast area, and the stars aren't in the right alignment for it to hit us. Instead, we could look forward to witnessing the beauty of a nearby cosmic explosion and appreciating the vastness of the universe from a safe distance. Are you still unsure? Join me as I take a look at other supernovae in history to help understand this better. Astronomers, both professional and amateur, have discovered several hundred supernovae annually since around 2000. In 2007, they found 572, in 2008, 261, in 2009, 390, and in 2013, 231. A supernova occurs when a star explodes with a tremendous burst of light. This can happen when a white dwarf is triggered into runaway nuclear fusion, or when a massive star nears the end of its life cycle. Either the main object, known as the progenitor, collapses into a neutron star or black hole, or it is destroyed and turns into a dispersed cloud. A supernova can have a peak brightness visible across the entire galaxy. After several weeks or months, this brightness starts to fade. The most recent supernova visible to the naked eye was SN 1987A, which was the explosion of a blue supergiant star in the Large Magellanic Cloud, an extension of the Milky Way. Hypothetical studies have shown that most supernovae are caused by one of two main events: the rapid onset of nuclear fusion in a white dwarf or the sudden core collapse of a massive star due to gravity. Supernovae have been studied in detail by astronomers and space telescopes, such as NASA's Hubble and Spitzer. The James Webb Space Telescope, JWST, however, is now the best for providing clear images of notable supernovae. Let's explore some of the amazing discoveries made possible by this technology. For example, by observing water vapor in protoplanetary disks with NASA's James Webb Space Telescope, researchers recently took a big step forward in understanding how planets form. The Webb telescope demonstrated a physical process in which solids coated in ice drift from the far reaches of space. Even more intriguing, scientists have used NASA telescopes to find the farthest black hole discovered so far in X-rays. This black hole, with a mass roughly equal to its host galaxy, is in a phase of growth never before observed. Researchers detected evidence of a growing black hole only 470 million years after the Big Bang by combining data from NASA's Chandra X-ray Observatory and JWST. This finding could help us understand how some of the universe's earliest giant black holes formed. The JWST is often hailed as the most powerful telescope ever built. It has also found free-floating planets, about the size of Jupiter, that aren't orbiting any star. The JWST found around 40 pairs of these objects while observing the Orion cloud. Known as Jupiter mass binary objects, or jumbos, these things are too small to be stars but don't fit the usual description of planets, as they aren't orbiting a parent star. Researchers are still working to understand what these unusual objects are. You may also find it interesting that the phantom galaxy is challenging to see at night, yet its brightness can be seen clearly, especially when Webb takes infrared images of it. The galaxy, also known as M74, has a perfect spiral shape and is filled with stars. Hubble's optical image shows arms extending outward from a bright center, while a new Webb image shows structures that look like filaments made of dust and gas radiating heat and extending from a bright center. The color of the core appears as a bright electric blue. This new image reveals star-forming regions spread out along the galaxy's spiral arms in infrared light. Optical and infrared studies of the galaxy are displayed in a stunning composite image made from pictures taken by the Hubble Space Telescope and the Webb Space Telescope. The European Space Agency noted that adding Webb's observations at longer wavelengths will allow astronomers to locate star-forming regions in galaxies and precisely measure star masses and ages. Groups have been getting more familiar with the small particles of residue drifting around in space between the stars. Certain individuals believe that cosmic explosions might have significant importance or connections, having studied them in detail and compared different sources. But do these celestial events relate to religion? Can cosmology and religion go hand in hand? Cosmology and religion have been connected since ancient times, almost like two sides of the same coin. Cosmology has always been an important part of faith and folklore. Astronomy and cosmology play a role in many religions and cultures around the world and have been intertwined for centuries, especially in the early days of stargazing. Ancient cultures worshipped celestial bodies, as shown by artifacts found in their homes during the Stone and Bronze Ages. Northern European talismans and stone walls depict constellations and star arrangements that correspond to past star positions, especially the circumpolar constellations. These artifacts date back 30,000 to 40,000 years. In many ancient religions, stars circling the northern hemisphere were associated with death, darkness, and the afterlife. The Aztecs believed that the god Tezcatlipoca was connected to the northern stars. In China, there was a shrine for the god of the North Star, and people may have revered these stars to keep track of time since the stars' positions could tell them the season. As farming improved, people needed to keep better track of the positions of the sun, moon, and planets for accurate timekeeping, which also led to reverence because of their importance to survival. In the ancient Egyptian calendar, observing the heliacal rising of a star helped them predict the annual flooding of the Nile. Astrology emerged from the idea that events on Earth were closely connected to celestial occurrences. Astrology predicts daily life based on the belief that celestial bodies, especially planets and stars, can influence or foreshadow earthly changes through their arrangements, known as constellations. Believers think that understanding how planets and stars affect life on Earth allows them to foresee the future and influence the fates of people, groups, and nations. Astrology was long regarded as a science, though many people today believe it conflicts with modern Western scientific findings and theories. Greek philosopher Anaxagoras was the first known person to challenge religious customs about cosmology. He was arrested for believing that celestial bodies formed through evolution and that the sun was a massive burning stone rather than the god Helios. Although he was acquitted, he had to leave due to his unconventional views. During the Renaissance, Christian orthodoxy clashed with the academic community's secular views. The trial of Galileo Galilei by the Inquisition is the most famous example of these conflicts, but many astronomers were deeply religious and tried to reconcile their beliefs with new scientific discoveries. Since technology and scientific breakthroughs have advanced, most people believe it's crucial to use our resources to prevent natural disasters that could alter the course of history. It's worth discussing why preparedness is important. Being prepared means that people in a community are aware of natural hazards and risks they face and are taking steps to make their community more resilient and capable of recovering from disasters. Natural disasters can happen quickly and might take years or even decades to rebuild and heal from. For instance, earthquakes strike suddenly and intensely, with no warning. Identifying potential hazards and making plans can reduce the risk of severe injury or death in an earthquake. Though we don't know when the next major quake will occur, we can prepare now to lessen its impact. For other natural disasters, it's equally important to be ready. The Betelgeuse Supernova shows how devastating such events can be for humans. Reports suggest that life cannot survive on the surface of a planet near a supernova. If a habitable world orbited Betelgeuse, at least 4 miles of its surface would likely be vaporized into space. In the worst case, an icy world the size of Earth with an ocean beneath its surface might lose half of its diameter. However, a planet in the habitable zone around Betelgeuse might survive, but it would face serious challenges. The planet's crust would need to be thick enough for people to dig deep underground. Additionally, the world should avoid a strong neutrino burst, as this could overheat human bodies and destroy electronics. The planet would also need to pass through an opening in the plasma wind that forms after a star dies. Survivors would need to hide for decades or even centuries, as the surrounding cloud could emit lethal radiation even in brief bursts. Gamma-ray bursts could still pose a danger from a nearby neutron star remnant or black holes with accretion disks. The post-supernova environment would make rescue missions nearly impossible, as finding survivors buried deep within the planet's crust would be extremely difficult, with no visible traces of the original scene. But since Betelgeuse is so far away, it's unlikely that such a disaster would affect us. Our beautiful planet is not in danger from cosmic explosions. Instead, they contribute to background radiation, which benefits our satellites and space telescopes, providing scientists with valuable data on high-energy cosmic phenomena. Our existence is thanks to stars like Betelgeuse, which exploded long ago before our solar system formed. This is why there are no recent supernovae nearby. I hope you enjoyed this fascinating journey through the universe. What do you think about Betelgeuse? Let us know your thoughts, and if you'd like to see more, please like, share, and follow.